We're asked to find solutions to each of the trigonometric equations that you see. So the first one here, what you're going to do, you're going to subtract 2 radical 3 on both sides. So what that gives you essentially is 4 sine x is equal to minus 2 radical 3. Dividing both sides by 4 will solve the equation for sine x. So sine x is equal to, now negative 2 over 4 is negative 1 over 2, right? So essentially the answer is minus 3 over 2, minus radical 3 over 2. So as you know, x can be many different angle measures, sine of which gives you negative radical 3 over 2, right? You know it's 4 pi over 3 is possible, 5 pi over 3, right? The next one after that would be 2 pi added to that, right? 2 pi would be 6 pi over 3, right? So 10 pi over 3 is the next angle. And 6 pi over 3 plus this is 11 pi over 3, etc., right? So notice that we can't combine these two types of solutions with only one solution, right? Because if we add pi over 3 to this, we get this one. But then the next one is going to be 5 pi over 3, the distance, right? The difference between these two is not the same as the difference between these two, right? So we have to have two separate solutions. Sometimes you can, as you will see in the next example, express many different angles under one solution. But this calls for two separate solutions, again, because the distance here is not going to be the same. The distance here is pi over 3, but the distance between these two, the second and third one, is 5 pi over 3, right? 5 pi over 3 plus 5 pi over 3 gives you 10 pi over 3. And you see the distance after that is pi over 3, right? So separate solutions. So that means the first, the solution can be expressed as taking the first one and adding or subtracting by means of writing plus minus 2n pi. Now 2n pi, if n is an integer, you subtract or add 2 pi as a result, or multiples of 2 pi, because n is an integer, you will get the same type of angle position, right? The angle measure will be different, but the position will be the same, right? And the same thing for the second type of solution, which is going to be 5 pi over 3 plus minus 2n pi, right? Because we know when n is equal to 1, adding the 2 pi will give you 10 pi over 3. The same thing here, when n is equal to 1, adding the 2 pi will give you, from this to this, 11 pi over 3, right? Because 2 pi is essentially 6 pi over 3. 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. And again, we have two solutions listed because the distances between the first and the second one, and the second one and the third one, are not the same, right? The first distance is pi over 3, the second distance is 5 pi over 3 between these two, right? So this calls for two separate solutions. That's why we listed the first one, 4 pi over 3 plus minus 2n pi. The second one is 5 pi over 3 plus minus 2n pi. And why minus again? Because you can go in the unit circle in the negative direction when you start counting the angles, right? In the negative direction, negative angle measures, keep in mind that they still can give you the same types of positions, even though the angle measures look different, they're negative versus positive. That's why plus minus theoretically exists, right? It calls for all solutions. Because this question, what you need to do here is to find all solutions, right? So you need to take note of the negative angle measures as well. Now, in the second example, tan of 3t is equal to 1. We know tan of, you know that 3t can be set to pi over 4, because tangent of pi over 4 is equal to 1, right? Sine of pi over 4 is radical 2 over 2. Cosine of pi over 4 is radical 2 over 2. Sine over cosine gives you the tangent. Since radical 2 over 2 divided by radical 2 over 2 is 1, tangent of pi over 4 is also 1, right? So we set the angle measure 3t equal to pi over 4. We just substitute that. Now keep in mind, there's another angle measure. In quadrant 1, tangent is positive for the pi over 4, but in quadrant 3, the tangent is also going to be positive, because the sine and cosine are both negative in quadrant 3 of the unit circle. Thus, we know that 5 pi over 4 is also possible. Tangent of 5 pi over 4 is also going to be 1, because the cosine of 5 pi over 4 is negative radical 2 over 2. The sine of 5 pi over 4 is also negative radical 2 over 2. Thus, their quotient will be positive and will be 1 as well. Okay? So now take a note of this. If you add 2 pi over 4, 2 pi, or in other words 8 pi over 4, you will get 9 pi over 4. If you add 2 pi to 5 pi over 4, namely 8 pi over 4 plus 5 pi over 4, gives you 13 pi over 4. Now notice there is this time the same distance between these solutions, unlike in the first example. So that means if it's the same distance, and the distance is precisely pi, right? Pi over 4 plus pi gives you 5 pi over 4. Plus another pi gives you 9 pi over 4. Right? 4 pi over 4. You can think of 4 pi over 4 being the same as pi. Right? Because look at the denominators are the same. Look at the numerators. The numerators are different by a difference of pi, right? I mean 4 pi. Pi plus 4 pi, 5 pi plus 4 pi, 9 pi plus 4 pi, 13 pi. So that means we can express a single solution for all of these angle measures, unlike the first example. So that means now before you do that, you have to divide the t, the 3t by 3, right? So you're going to essentially divide both sides by 3. Okay, for all of these, this is the wrong way to do it, like that, right? So you're going to divide all of these by 3. So as a result, t will be equal to pi over 12 plus minus, now plus minus again, because we can list everything under one solution, but making sure that all of these are divided by 3. And again, plus minus, because the minus makes sure that all solutions are accounted for, also going in the negative direction of a unit circle, right? The clockwise direction. So plus minus, and like I said, the difference here was pi, right? So we take the pi, but since we're dividing by 3 everything, we're going to have to divide by 3. But also making sure that we don't just get one type of 2 sets of angle measures, but all possible sets of angle measures. So that's why we have to say n. Okay? And I got to make sure that I have to say n being any integer, n any integer. It's very important, right? Because if n is not an integer, this answer will not work. N has to be an integer for this solution to be valid. Okay? So now, the next example, we have 2 cosine squared u is equal to cosine u. Subtracting cosine u on both sides will give you a quadratic equation pretty much in terms of cosine. So what you're going to get is 2 cosine squared u minus cosine u is equal to 0. Now you can factor this, you can put the cosine u out, and you can do it like this. 2 cosine u minus 1 is equal to 0. So that means cosine of u can be set to 0, or 2 cosine u minus 1 is equal to 0. Adding 1 on both sides gives you 2 cosine u is equal to 1. And that means cosine u is equal to 1/2. So now we have cosine u is equal to 0, or cosine of u is equal to 1/2. So notice that cosine of pi over 2 is equal to 0, right? We know that. Pi over 2, also 3 pi over 2, right, etc. And then what is the next one going to be? Basically, the difference will always be pi, right? The next one is going to be, what, 2 pi over 2 plus 3 pi over 2 is 5 pi over 2, right, etc. So the difference is always pi. Okay, and here, know that the cosine of pi over 3 is 1/2 in quadrant 1. We also know that cosine is positive in quadrant 4, and namely 5 pi over 3 for the cosine will also give you 1/2. Cosine of 5 pi over 3 is also going to be 1/2. Okay, if you add the 2 pi to pi over 3, or 6 pi over 3, you will get 7 pi over 3, right? So now this is enough to tell you that the distances will not be the same. So you will need two different solutions for these angle measures, two types of solutions. So with this solution, you will have three solutions, right? Because you can list this under one solution, but here we will need two solutions because the distances are not the same. Whereas here, the distances are always going to be pi, right? Here, the distances are not the same. Look at the numerators. There's 1 pi and then there's a 5 pi. So you needed a 4 pi. But then you need only a 2 pi to get to the numerator after that, right? So the distances are not the same. So as a result, we can express the solution as pi over 2 plus minus n pi. And why not 2n pi? It's not 2n pi because the difference here is not 2 pi. The difference is going to be always pi, right? Or 2 pi over 2, which is the same thing. The difference is pi. N pi makes sure that when n is an integer, it will account for all possible solutions, including the negative direction for the angle measures. Now that's the first solution. Let's actually bring it to the left so we have more space. So now the second one is going to be taking the pi over 3 plus minus 2n pi now, because the difference between pi over 3 and 7 pi over 3 is going to be 2 pi. Right, or 6 pi over 3, which is the same thing. So the distance is between the first and the third one is 2 pi. And n makes sure when n is an integer that we account for all possible positions, for all angle measures possible in the positive and negative direction. And now the third one will be 5 pi over 3. Like I said, we needed two solutions here, right? So in total, this is going to be the third solution. So 5 pi over 3 plus minus 2n pi. So as you can see, this is going to be the entire solution, and making sure to indicate that n is going to be any integer. And make sure you always indicate that, because if n is not an integer, let's say if it's a rational number or fraction or irrational number, this is not going to be a solution. It's not going to work. N has to be a whole number, an integer, a negative number, right? That is going to be an integer. Like 1, 2, 3, 4, 5, 6, 7, 0, negative 1, negative 2, negative 3, negative 100, negative 1,000, right? N is going to be an integer. Now, in the next example, if you add sine squared on both sides, and you're going to subtract 1, what you're going to get is going to be sine squared theta is going to be equal to 3. I'm just switching sides of the equation. I'm putting sine squared theta on the left side, even though it should be on the right. I'm just reflecting, basically. This is just a reflection, just to see it better. So we will have 3 on one side and sine squared theta on the other, right? So as a result, if you take the square root of both sides, you will get plus minus square root of 3. Now here's the problem. That means sine of theta is equal to plus minus radical 3. Now the problem here is that we know, since the amplitude of the sine function is 1, this is the parent function sine of theta, we know that the minimum value for sine theta is negative 1, and the maximum value is 1. So that means sine of theta can be between these and including the endpoints. The minimum value sine theta is -1, it cannot go lower than that, and it cannot go higher than 1. But the problem is that radical 3, negative radical 3, is less than -1, the minimum value allowable for the sine. Right? So sine of theta can never equal negative radical 3. And also positive radical 3 is going to be greater than the maximum value that the sine of theta is allowed to have. So as a result, this gives you no solution. Yes, it's possible. Sometimes there is no solution. Please be aware of that. Not always will you be able to solve these types of equations. Now, in the last example, to find the value of x, you have to take the e on both sides. You will basically transform these respective sides into exponents for the e. Right? So what I'm saying is you're going to have e to the ln of sine x is equal to e to the 0. Now you know e to the ln of sine x is equal to sine x. Right? And the formula that I've used was e to the ln of x. Recall that e to the ln of x is equal to the input of the ln. Because the e's and ln's, they cancel each other out, so the result will be x. So in the same way, e to the ln of sine x, and I'm going to make this in blue so that you can see, e to the ln of sine x is equal to the sine x itself. Because the e and the ln cancel each other out, they make the input come forward. So now, basically what that means is that sine x is equal to e to the 0 as a result, right? E to the 0 is 1. And you know sine of pi over 2 is 1. Sine of pi over 2 is equal to 1. And multiples of 2 pi being subtracted or added to pi over 2 will give you the sine of that angle measure, also 1. So that means we can add or subtract multiples of 2 pi. And we will get the same result, right? So any integer. So I hope this was useful. Thank you so much for watching, and I'll see you in the next video.